We are continuing the discussion on the square root property, page 2, with our third example. We are going to solve negative 3x squared minus 5 equals 22. And you'll notice the same issue is here that we had in the previous video. There's no x to the first power in this equation. There's only x to the second power. And that indicates to us it's actually an easier problem to solve than had there been both the x squared and the x. Let's start with step 1. Step 1 says to isolate the squared portion. So first we're going to add 5 to both sides of the equal sign to move the 5 over. These guys will cancel and it will leave negative 3x squared equals what? 27. And then we're going to divide next. We're going to divide both sides by the negative 3. So it's negative 3x squared divided by negative 3 equals 27 divided by negative 3. Now the negative 3's cancel. Let's move up here. And that gives us x squared equals a positive over a negative is a negative. 27 divided by 3. 3 times 9 is 27. So that looks like a 9 to me. 27 divided by 3. Okay, so we've concluded step 1. We've isolated our x squared. Let's move to step 2. Step 2 says to apply the square root property, taking plus or minus the square root of both sides. Okay, so to do that, we'll take our x squared equals negative 9. That's the result of the previous step. And we'll get rid of the square by taking plus or minus the square root of both sides. Plus or minus the square root of negative 9. Okay, so we've isolated the x. We just have to do step 3. We have to simplify our answer. So x is equal to plus or minus, well, check it out. We have the square root of a negative number, and we just learned recently about the imaginary numbers. The imaginary number I is equal to the square root of negative 1. So whenever we get the square root of a negative number, the very first thing we do when simplifying is factor out the I. In other words, we're going to pull out the square root of negative 1 and then rewrite it as I. So that's I times the square root of positive 9. You see that? We factored out the square root of negative 1 and we renamed that I. Well, what is that equal to? That's plus or minus I times, what's the square root of 9? It's a number whose square equals 9, so it's 3. And finally, we put the 3 in the front for our final answer, plus or minus 3 times I. So we have two solutions here, and one is a positive 3i and the other is a negative 3i. Let's do a check. Now this is something I don't always take the time to do, but it's a good idea to check. Let's check, let's check the positive answer, positive 3i. So let's say let x equal 3i. We're going to plug it back into the original equation and see if it makes both sides equal. Negative 3 times 3i to the second power minus 5, and this becomes a question. Is that equal to 22? Negative 3 times 3 times I is 9 times I to the second power. Minus 5, bring down the equal sign, bring down the 22. It's still a question. I don't know if they're equal. Now, see, what I did here is I did 3i times 3i gives me 9i squared. But I know what I squared is. I squared, I'll put it over here, I squared, I know, is equal to negative 1. That's something I know because I itself is the square root of negative 1. So I'm going to replace this with negative 3 times 9 times negative 1, that's the result of I squared, minus 5 equals question mark 22. Okay, 9 times a negative 1 is negative 9. So I have negative 3 times negative 9 minus 5 in the question. Does that equal 22? I'm hoping it does. Otherwise, something went wrong. Let's see. A negative times a negative is a positive. 27 minus 5. Is that equal? Oh, it's looking good. 27 minus 5 is 22. That is equal to 22. So yes, this is a good answer. We checked it. Now you can check the other one, negative 3i, in the parenthesis and see that you got the same result. Let's scroll down to the next problem. Scroll. Okay. Solve this mess in the parenthesis squared plus 24 equals 0. So for step 1, instead of saying isolate x or isolate z, I'm saying isolate the dude that's being squared, whatever he is. I don't care what he is. He's a big parenthesis this time. We're going to isolate him. We do that by subtracting 24 from both sides. So that leaves, let's see, these guys cancel. We get parenthesis z plus 4 squared equals negative 24. Okay, we did it. We isolated the expression that's being squared. In step 2, we're going to get rid of the square. Apply the square root property by taking plus or minus the square root of both sides. It gives us z plus 4 equals plus or minus the square root of negative 24. Okay, we're not quite finished. Well, let's rewrite that as z plus 4 equals plus or minus, let's see, pull out the I, and it leaves the square root of 24. But there's a perfect square factor in 24, right? It is 4 times 6, and 4 is the perfect square. So that would be the same as plus or minus I times the square root of 4 times the square root of 6. Anyway, it brings us over here to z, I'm bringing it down, plus 4 equals plus or minus I times the square root of 4 is 2 times the square root of 6. Let's move on to step 3. Step 3 says to simplify to finish. I'm trying to solve for z, and I'm almost there. So let me just simplify one more time. Z plus 4 equals plus or minus 2. Now, it's usually written in the text as 2i times the square root of 6. Now, I know we like i's in the back usually to get the standard form, but you know the thing we talk about. It might look like it's under the radical sign if you don't hook it the way that I do, so I put it in the front like the book does. Okay, we're trying to solve for z. The last thing we have to do is subtract 4 from both sides. Here it cancels. Z equals negative 4 plus or minus, oh, that's terrible. Let's clean that up. Plus or minus 2i, well, let's see, yeah, it's 2 times I times the square root of 6. So there are our two answers. One of them has a plus sign, it's negative 4 plus 2i squared root of 6, and the other one has the minus sign, minus 4 minus 2i times the square root of 6.